Morning, everyone. Welcome to this session. I think we can start. Our time is exactly 8:30, so we can start with our work. However, I realize that there are very, very few students here. What is happening? Is there anyone who can explain? Mary Jill,
Morning, sir.
morning.
I think people are writing today. That's why some of them are.
That tendency.
Yeah, that's why.
Okay, but anyway, it won't stop us. Let's continue with our work. For those who were here yesterday, I think I introduced a new chapter, which is chapter 7, called cluster sampling, and we did some examples on how to estimate the population mean, population total, and variance under cluster random sampling. So we realized that in some cases you can find that you don't have the capital letter M, which represent the elements in the cluster. But in that case, if the element in the cluster is not given, so we are advised to use capital letter M bar, which is equal to M bar, which is equal to summation of Mi over Ni, which is the average of all the elements in the cluster. So I think we are done with that. Then I said we are going to continue with the example 7.3, if you still recall. Example 7.3 is on page 16. Let me just go to the window journal so that we can start with our work nicely. So we can just be patient a bit while I'm still going there. I think I'm almost there. There we are. I think it's lecture 22. It's lecture 22. It's still the continuation of cluster sampling. So where we are going to concentrate on example 7.3, which is on page 60. Sorry. It's page 60 on the lecture notes. Okay. And I realized that this example is the continuation of example 7.2. And then our main aim is to estimate the total income, okay, of all the residents of the city, and then later we place a bound on the area of estimation. So in this case, they gave us the M. M is given in this case, elements in the cluster, which is equal to 2,500. Are you there? On page 60, example 7.3.
Yes.
Okay, thank you very much. Now it says use data in table 7.2. That is an example 7.2. That is table 7.2 is on page 58. Okay. To estimate the total income of all residents of the city and place a bound on the area of estimation. So in this case, you just want to estimate tau, isn't it? And then later you find the estimated value of that estimator. and then is then that you can find the bound, which is equal to the square root of the estimated var of the estimated population total under cluster random sampling. Those are the three things that we want to follow. So, can you please try to do that one? So we start from the formula, obvious, which is equal to what? The formula of estimating population total, if M is given, is written as what?
My bar.
It's, yes, thank you. It's My bar. Okay, and remember M is given there, so obvious we have it. What about Y bar? Y bar is the one that we have calculated in example 7.3. You still remember what is that? So that means 2500 multiplied by the estimated mean under example 7.2. You got what?
8801.
Yes, thank you. 8801.
Comma
Point
3245.
324. Okay, let's say 325, something like that. Okay, so what is the answer now?
45.
It's 45. Oh, 3, is that 8801, comma 3?
3245.
Yeah, it's 325. It's fine like that. So, but what is the final answer in that regard? Can you have your calculators?
22003311.
220033
11.
11. So this is
Comma
the comma 2.
25.
Okay. Comma 2 what?
5.
5. Okay. So this is our estimated population total of income of all the residents on the city. So now we want to find the estimated var of that estimate. So which is the estimated var of cow head? And you still remember the formula? The formula is what? It's N, which is the population size.
M squared
M.
times variance of Y. So can
Come
we use
again?
that one? Why don't we
Which
use
one?
that one of M squared times variance of Y bar?
Okay, let me see. Let me write what you're saying. You're saying M squared, okay, times
Variance of Y bar.
estimated one,
Yes.
okay. Then you plug what is required there. You have the estimated var of the estimated population mean. You have it.
Yes.
Okay. Okay, let's see. It's a 2500 squared multiplied by what?
653.
653. Okay. 653. What?
653769,
Comma.
2312.
Like this one. Then later, what is the final answer?
4,086 times 10 to the power of 12.
4,086
times
times
10
10
to the power of 12.
to the power of 12. Let me just see something here. Okay, there is another formula here. I just want to see whether we can get the same answer. However, remember when we were estimating the variance of the estimated mean, we didn't have the capital letter M, isn't it? So it won't be confusing to take the one that doesn't have the capital letter M and combine with the one with the elements of the clusters. Because normally, if this one estimated variance of the estimated population mean is calculated under the situation where M is unknown, and this one, the estimated population total, is calculated in the situation where M is unknown, so we can be able to combine them together. So, but in this case, it was not given then before when we calculate the estimated variance of the estimated mean. But this time, M is given, and we just want to estimate the population total. So can we combine this one, even though the formulas are okay? Combine this one with because we know that this one is coming from where M is unknown, and this time around M is known. Okay, let's go to that other formula that we were supposed to use rather than this one and see what are we going to get. Okay, the other formula is what? Just want to see something. Power of tau heads. It's what? We just want to see whether we are going to get, if we can't get the same answer, so that means we combine something that are not supposed to be combined there. So I want the formula. It's what?
N into N minus N.
N into N minus N.
Times
Then there was
S,
the variance divided by N.
N into N minus 1.
Or N minus 1. That's the formula.
Sir,
Yes.
It can't be n minus 1 here. It can't be n minus 1 here. It's just over n, which can also be extended as in this way. Let me see. Which can also be extended as n minus n. Okay, summation of yi minus can you say y bar mi all squared divided by what? N into n minus 1. Isn't it? But here we don't have n minus 1. Is that okay? Are we still together, guys? Okay, so now let's substitute. The population size from the previous one was what? From the previous example, it was what?
415.
415.
415, yes. 415 minus n
25.
25. Then you close it. So now comes to the variance. Estimated variance is what?
25189 squared.
Yes. 251
89
89, because it was a standard
squared.
deviation, you have to square it. Okay. Then you divide it by what? By n, not n into n minus 1, isn't it? Which is 25. Can you try to calculate this one?
Four point 1076.
4.10 Are you sure?
1076
176.
times 10 exponent 12.
So they're the same. Almost. No, so that means there is no effect anyway. It seems as they are almost the same. Maybe it's the matter of just rounding somewhere. Where this one now. Where this one. This one. I think it's the matter of just rounding somewhere. I don't know. They are almost the same. They're almost the same. So we can use one. I will consider. Okay, so it's fine. Any question? Okay, let's find a bound here. For using this one, just find a bound. And this one, find a bound. Want to see this one? You know how to find a bound, isn't it? Bound is equal to 2 times the square root of the estimated var. Even here, 2 times the square root of the estimated var. Let's start here. Let's find the bound here.
It's 405.
405. 5
3472,
3 4 7 2, like this.
861.
Okay, what about the other one?
404,
404
2796,
2796
062.
062. Now, they're still they're almost close. They're almost close. But let me just advise you, they're almost close. All of them, we can just say they're correct. But I can advise you to do it in this way. For example, just write it in this one. For example, 7.2. Okay. Hey, 7.2. Okay. M was unknown. Okay. And here, example 7.3. M now is known. Okay. So here you calculated Y bar. Okay. And we is the continuation of example 7.2. So obvious, and you know that tau head is equal to my bar. Okay. So it's fine because this one is coming from unknown and this one is coming from known. So it's the combination of the two. So okay, I can recommend that you can either use that formula of the one that we were talking about here. It's fine. You will see and consider it. You can use this one, even though they're slight different, but they're almost the same. And somebody can use this one. So there is no harm on that. So let's just leave it in that way. Unless if there is any question. Okay, let's go to example 7.4. Example 7.4. It's on page 60 again. Page 60. 7.4 on the lecture notes. And they are saying we are using data summary in table 7.3. I hope you have that table 7.3, to estimate the total income again of all residents of the city if M is unknown. Okay. In this case, M is unknown. And then we just want to calculate the total income again. And then place a bound. And then place a bound. Okay. And they gave us the population size, which is 415. And then the sample size is the same thing, actually. And then summation of y, or still the same thing. Summation of y still the same thing, which is equal to 1329 000. It's the same information on example 7.2. Okay. So the estimated population total income is going to be defined by what? Remember, capital letter M is unknown. And I gave you the formula to find the estimated population total if M is unknown. What is that formula? It's equal to what?
It's NY bar.
Yes, thank you. And that is the formula. And the N, you know, that is 415. Then Y bar. Y bar, remember, it's not the same as Y bar that we used before. This Y bar is equal to summation of Yi over N, isn't it? So what is the answer there? Summation of Yi over N. Remember, summation of Yi is 132, 9,000. Then you divide it by 25. Then what is the answer?
2206
2206.
1400
2206
14
14
1400.
14 again.
No,
Like this?
1400.
Oh, thank you. 1400. So you take it and put it here. 2206 1400. Then you get the estimated population total. What is the answer?
No, say, say.
Yes, yes.
The answer I was giving you, it's for the estimate.
It's the final for the estimated total. Oh.
It's
So
not
I
for
was
the Y
looking
bar, it's for the whole thing there.
for the Y bar is what? I was looking for the Y bar.
It's the final answer, yes.
Y bar is 5316.
Okay. So isn't that we have to follow this procedure? 50?
316.
160.
Yes.
That's it. Okay. So 23160. So the final here is what?
2206.
06.
1400.
22061400. So what, everybody got it? Okay. So this is the estimated population total when M is unknown. Remember, we just want to find the bound, isn't it? So you have to find the estimated var of that estimate, which is equal to what? What is the formula for the estimated var of the estimated population total under unknown? n open brackets n minus n times what?
S squared over n.
Squared over n. And this one is different from that one or what? So what is the variance, the estimated variance of that? Let's go to table 7.3. They said we have to use table 7.3, isn't it? So it's 25189 again. 217. Oh, it's for the what? It's for the income, remember? So it's what? We can't use that one, yi minus y bar mi, which is equal to 25189. We're going to use the simple variance of income, which is equal to what? According to that. 15, 25.
Why are we not using the other ones?
That one is for it's when m is known. Remember, this one, the last one, yi minus y bar mi. This s y squared is not the same as this one. So this one is for yi minus y bar mi. This one is for yi minus y bar mi. It's the variance of yi minus y bar yi. This one. Okay, but this one is the simple variance of the what? Of the income. They are different. So therefore, you have to use 21784, I suppose. Because in this regard, m is unknown. So you have to use 21784. Are we together? Then you divide by n, which is 25. Remember, on table 7.3, we've got the residence, we've got the income, and we've got the Are you still there? Hello? Hello? Can you hear me?